And again, saying good day to everybody attending this second webinar presentation in a series of POTA-related webinar presentations. And today, the topic will be efficient shell-based access to the POTA services and virtual machines. So last time we started off with graphical UI-driven provisioning of POTA VMs. Today we're doing a little bit different way of doing the provisioning and access of the machines using OpenStack CLI tools and SSH configurations for more fine-grained host access. So I'm mostly going to leave this as the only part where we'll be seeing the GUI today. I just want to highlight the fact that I'm using the default quota for this project, and I have already allocated one IP for my machine, and then another IP has been allocated for a colleague's machine. So, as is a very typical case with projects with default quota, the default quota for floating IPs gets exhausted very quickly. So I have an allocation to one of these IPs, and I can still use that. But going forward, I would either need to use more quota or start applying some kind of a fancy SSH config to utilize a jump host and get the most out of these existing IP resources. So I'll give you a brief glimpse on what is the idea in today's presentation. So last time we created a virtual machine instance as is seen on the right, and corresponding private public key pair to be able to access that virtual machine instance. And furthermore, we created a security group that allows SSH traffic with a TCP port 22 for us to be able to access that virtual machine instance. This webinar, in this webinar presentation, we are going to build on top of this existing facility or existing setting where we already have the one instance, and we are going to introduce additional hosts on top of that. So effectively, we will be turning our first host in the OpenStack project as a kind of a jump host, and we will be building further hosts behind that that are going to be in the private network section. So here the cloud represents public internet, and while we have SSH configured for the jump host so that the firewall accepts any traffic from the workstation, the web server in this picture will be in the private network, and it will not have access anywhere from the public internet, but rather we will be using jump host to access all of these hosts. But without further ado, let's get going. So this is supposed to be about CLI access and shell access, so that's why I'm now going to the terminal. So in the previous picture, you saw this workstation here on the far left. In this case, I will be using a workstation again called Delhi, which is the same one I used in my previous presentation. Now, I'm going to create first thing this jump host, and then I'm going to start creating an SSH configuration for accessing the remainder hosts. So the first thing I'm gonna do is run nova list, and this gives me an overview of the resources that are currently in use. These are not my machines; these are other instances created by some colleagues who I share the project with. Instead of the image name, I will reference the image ID, like so. So booting CentOS 7 image with the flavor Tiny, which had the 1 CPU and 1 gigabyte, as we remember from past webinar. And that should boot us our first machine. So here we see that it's currently building. It is using the webinar key and the CentOS 7 image. And if I do a nova list, I should now see this machine as a new host here. Okay, what would be next? So next up, we want to do floating IP for this particular instance. I think in this case, I will also assign it via the UI, like so, just like we did the last time. So you get a little bit refresher how that is done. Now we have the floating IP. So getting back to arrangement here, we have our first virtual machine related to this exercise that we're going to now dedicate as a jump host. And this is now the starting point for creating a so-called SSH config. So I'm going to, in my workstation machine, go into the .ssh directory and then start editing a config file. If there is none, you simply create one. And the first thing I'm going to do is enable agent forwarding for all the connections. This is okay if you know that all the machines you are accessing are administered by yourself or a trusted third party. So this effectively means that we're going to be forwarding our private keys for consecutive authentication into further machines. So if there would be, let's say, a third-party root on the jump host that you could not trust, then this would not be a recommended action. But since this environment is completely controlled by our project members, I'm going to enable agent forwarding. And next up, I'm going to describe my jump host. So I'll put it as host name, the IP. Actually, I'll close this now and get back to the Nova listing. So JN webinar jump host has the floating IP such and such. And let's see if that works. I have an SSH agent running. I have loaded my webinar key into that particular SSH agent. So I'm going to try now to form an SSH connection into jump host. Let's see what happens. Okay. So clearly, connection is not being formed. So most likely we are missing this security group allowing the inbound TCP port 22, which is fine because we can add one. So we need another Nova command, Nova sec group create webinar, for example. Nova help sec group create if I'm missing something. Just needed a description there. So then we do Nova sec group add rule and then webinar TCP. This is a port range. I'm just using the SSH port. And then we would need actually our local IP address. So let's go to ip4.me. It's 1.72. So I'm effectively getting the IP address of the Delhi server. 193.166.1.72/32. And then we're going to do Nova add sec group to, I forgot. I need to check for the name of the server again. GN webinar jump host. Nova add sec group JN webinar jump host. So just a minor detail we needed to add before this starts to work. And furthermore, I have previously used this IP, so I need to clear out an offending IP again from my known hosts file, which is no biggie. So, and finally, we are able now to access our jump host. So that's part one. We have now completed this virtual machine instance turned jump host creation. The next part would be to create ourselves a web server. So I'm going to use the exact same commands we used previously to do to that end. And in this case, I think I'll use flavor mini instead of tiny and call it JN Webinar Web Server. And while we're at it, we could, of course, create additional servers too. So let's say we create database. And then file server. Don't remember off the top of my mind if I have the quota for that, but hopefully we do. So now we already have JN Webinar Jump Host, which has the public IP address 86.50.170 and 104. And you can also see that here are the two public IP addresses that this project has available already taken into use. So now we're effectively going to use this one to the maximum efficiency by utilizing this jump host and making effective use of our resources before applying for more quota. Okay, so the provisioning of our web server, file server, and database is complete. Now what we can do is then take the IP address of the web server, for example, and add that to our SSH config as well. So let's do host web server. And now we're going to have to use the proxy command. So this is an SSH stanza that allows us to fire up additional commands in the jump host. In this case, we determine netcat 22. So effectively, we're going via SSH into the jump host and then forming a netcat tunnel and using agent forwarding to log in further into the successive web server host. Here I actually remembered that we might not have netcat installed here by default. We don't, so let's do sudo yum search netcat. And then sudo yum install nmap-ncat, which seems to be the netcat that we have available in this CentOS distribution. All right. This is working. So then I seem to have a good configuration here for accessing the .16 IP address, which was this particular web server host. So let's try that. So instead of IP address or public IP address, I am giving now just like a host name definition that is pointing into a particular host configuration in the SSH client config file. Okay, so remote host identification. Now I believe there is again similar kind of host key conflict. Yes, in known hosts. And now we have logged into our web server. And this is actually a situation that we could perhaps anticipate a little bit in our SSH config files. So as you are working with the cloud, you more often than not end up deleting resources and rebuilding them. So deleting and rebuilding via automation scripts such as Ansible. The first webinars here are concentrated on the web UI and CLI shell access. Of course, going forward, we will talk more and more about automation and how things are done in a nice scripted fashion. But in this case, I can also do Nova delete. Let's say we delete our database server like so, and do the rebuild for the same database to emulate the same kind of situation. So this can happen, and now again, this would result in a new host being created, new host key being created, and SSH client with its default settings would again give this complaint that remote host identification has changed. So for hosts like these that we know that they're going to be volatile or fluctuating quite a lot due to the rebuilds and whatnot, we can add some additional parameters such as user known hosts file equals dev null. So then we're actually not going to store the host file for this particular server anymore, and we won't get that complaint every time the server is rebuilt. Now I disconnect, log back in. So due to my disconnect, I believe I don't have my SSH agent open anymore. Let's do a little tweak. We're going to edit our BAS profile and put eval SSH agent here, and then SSH add webinar.key. This actually allows us to, each time when we log in here, to start the SSH agent and add the key automatically. So that's another tips and tricks section pointer to you in getting efficiency into shell access of Pouta virtual machines. Okay, but now let's see if our previously used command still works. So SSHL cloud user to web server. That is working fine. And cloud user to jump host. That is working fine. So what do we still need to add? This was kind of my target for today, that we would have database, file server, and web server defined. So let's put those in still. I'm simply going to replicate this configuration part. So, so this is something you didn't see at the beginning of the video either. I am sourcing my OpenStack project file. After this Nova list will work, and then I will get database and file server IP addresses that I'm still missing. So database was 19, and file server was 118. Let's see what happens when I try to SSH to database. I get offered a new host key, and the same thing with the file server. So this is pretty much the tip of the iceberg when it comes to SSH access to your Pouta hosts. So we have so far demonstrated accessing from the workstation computer the database, the web server, and the file server using our initially built jump host. And of course, we could start now building all kinds of tools for ourselves to this end. So in addition to the shell session, of course, we could build a chained port forwarding. So for example, we could access the web server's HTTP or HTTPS front page tunneled via the SSH connection. So only the one single port would be open to the public internet. Or the same thing towards the database with a SQL client. Pretty much sky is the limit here. So from today's webinar, I would pretty much like to leave the viewers with the idea that if you have run out of your project floating IPs, so if you cannot assign more than these two IP addresses, you do not necessarily need to apply for more IPs for your quota. Rather, you can utilize your existing IPs more efficiently by taking a jump host into use. And that's just one idea, so I leave the implementation to your imagination.